Hey guys, so what we're going to do today, it's going to be a little bit messy because I don't know what happened, but I can no longer use my dot cam in order to film this. So we are going to be using this right here, okay? This is not going to be a fun video for me to make, but we're going to have to get through it, okay? So let me get one thing set up and then we will get to it. When we are filling this out, I need you to make sure that you are paying attention to the video so that you know what the heck is going on. Again, you're not going to see me write things down, but I am going to fill them out with you. Do you understand? And also there'll be a copy of this in the Schoology Notes folder, so I need you to watch this video, follow along, and then if you need to get the blanks, go to the Schoology Note folder. So we're going to talk about a portion of Newton's third law, which is momentum. So what the heck is momentum? Now we've written down a fancy smancy definition in our GUS, which is that momentum is a property of motion where it makes things hard to stop. Hard to stop moving. So where inertia was, okay, this is where things are hard to start moving. Momentum is, it's hard to stop it from moving, okay? So inertia is it's hard to start, and momentum is the back half of it. It's hard to stop. So momentum is mass in motion. Mass in motion. So you're going to write down that first blank. Momentum is mass in motion. Mass in motion. Okay? So, momentum is mass in motion. Now, there are two things that are going to impact momentum. And you can already guess what one of them is. It's in the definition, and that is mass. So the more mass that you have, guess what? It's just like it's just like inertia. It's if you have more mass, you're going to have more momentum. It's harder to stop something from stopping you. If you think about football, football is a great example of momentum and inertia. If you're trying to block a 300-pound linebacker who's running at you super fast, it's going to be really hard to stop him. It's also going to be really hard to get him moving. Or trying to push him the other way. So the two things that affect momentum, the first one is mass. So in that line under says two things, you need to write down mass. And then we're going to do our arrows because I like my, whatever they're called, my relationships. So we've got a proportional relationship here. We have a proportional relationship or direct relationship. So as we increase our mass, we are going to increase our momentum. So this is what you have right now. As you increase your mass, so we have two things that affect momentum, mass. As we increase our mass, we are going to increase our momentum. Okay? Now, our second one is velocity. It depends on how fast something is. Now, velocity, if you look in your GUS, is similar to speed. However, it's a specific direction. Remember, it is a vector quantity, meaning that it has a magnitude, a number, but also a direction. What have we just talked about? That's a vector quantity that we need to have direction and a number for, or magnitude, net force. So we need to make sure that when we're talking about velocity, we say, okay, it's going to the right, it's going to the left, it's going up and down. But the same thing with velocity is that when you have velocity, your, totally lost my train of thought. It's the same thing. As you increase your speed, you're going to increase your momentum. It's going to be harder to stop something from going. If you've got a snail and you've got a semi and the snail is going 0.5 centimeters an hour and the semi is going 80 miles an hour, who's going to win? The semi. It's going to be harder to stop the semi. It's going to be harder for it to stop being in motion. So the velocity, as you increase your velocity, you are going to increase your momentum. So again, this is what we have right now. You need to have filled in the velocity. As we increase our velocity, we are going to increase our momentum. And look at this. We have the triangle of success. So what I need you to do for the triangle of success, what's on top is momentum. And guess what? It's not M. Guys, it's P, okay? I know, it's weird. It's very weird. But P represents momentum. So we're going to put P, and then we'll write momentum. Okay? And then we have our two variables, and we have mass for M and V for velocity. So we'll write those in too. Okay? So we have our triangle of success here. We have momentum on top, then we have mass here and velocity here. Remember, if they're right next to each other, we multiply. If they're on top of each other, we divide. Now we're going to go down here for units. What are the units for, oh my gosh, what are the units for momentum? Now, the units for momentum are kind of creepy, not creepy, but they're kind of a lot. So they are just simply kilogram meters per second. Yeah, okay? So you'll just need to remember the for momentum, P equals kilograms per meters per second. Kilograms times meters per second. The reason why is because we're taking the units from mass and we're multiplying them by the units of velocity. There's no pretty way to do this except kilograms meters per second. Okay, so you'll have to memorize this. We're going to go into the formulas for momentum, and then I'm going to do one of these questions with you, and you need to do the rest on your own, because we know how to use this. We don't need to practice a lot because you are familiar with it, and you're going to do more and more practice. But if you get confused, please come back to this portion of it, and then you can review how to do it, okay? So we have our formulas. Momentum. If we cover up momentum, we've got mass times velocity. So our momentum, P equals M times V. Okay? P equals M times V. Now we're going to go down to mass. So we cover up our mass, and we have, there we go. We have mass equals momentum divided by velocity. So mass equals momentum P divided by V. All right, next one, velocity. So when we look back over here, we're going to cover up velocity. Our velocity is going to be momentum divided by mass. So we have momentum divided by mass. Okay? Now, it's really important for us to remember what the units for the other ones are. Our units for mass are always going to be kilograms. So let's write that down again so we remember. Mass is always going to be kilograms, and velocity is actually always going to be meters per second, okay? Velocity is not like speed where it can be kilometers per second. It's going to be meters per second. So we're going to write that down in our triangle. And then momentum is that weird one, which is kilograms times meters per second. So this is how your triangle should look now. We've got our units up at the top, and then we have everything filled out. So what I want to do now is I'm going to do question 1 on here. It says, Mandy is running down the hill at a velocity of 2 meters per second north. Her mass is 20 kilograms. What is her momentum? So we're going to do the easy way. We are going to use our triangle. So we have our triangle here. We have our triangle. Now we need to figure out, okay, what goes at the top? Well, what are we solving for? We're solving for momentum. So we need to put our big letter P up at the top to remind us that that is what we are solving for, okay? Then, okay, what is left? We have velocity, which is 2 meters per second, and we have mass, which is 20. So mass goes here, velocity goes here. Plug and chug. So we have 2 meters per second, and we have 20. If they're right next to each other, what do? We multiply. So we're going to take 2 times 20, and that's it. So 2 times 20, since they're next to each other, 2 times 20 equals 40. Now, units. You have to have units, people, okay? You have to have units. 20 could be 20 ice creams melting in the hot summer sun on Mars, okay? I don't know what it is until you tell me their units. What are our units? Think about it. What is it? Okay, it is kilogram meters per second. Okay, meters per second. Yes. Kilogram meters per second. So it is going to be, the momentum is 40 kilograms meter times meters per second. So it should look like this. All right, I want you to try the other ones. Then when you're finished, I want you to check them on the notes page, okay? It is located in the all notes here part under momentum notes, okay? So when you are finished, please go ahead and move on to the next activity. As a reminder, any activity that I assign is due by the time I get back. And if you don't, you get a nice big goose egg in the grade book, okay? Work hard on this. Again, when I get back, we're going to do even more practice. I need you to try, all right? Don't just sit there and twiddle your thumbs and do nothing and cause a disruption. Because if you do cause a disruption, remember, you get a detention when I get back. So, be good, be here, be on your best behavior. You guys got this. Stay curious. I'll see y'all when I get back.